Hello and welcome to lecture 19 of Introduction to Computational Literary Analysis. And today we're going to look at sentence structure analysis, syntactic analysis using SpaCy. Okay, here we go. Okay, at this point, all of this stuff should be familiar. So, yeah, today we're going to look at syntactic analysis. So up until now, we've basically been looking at the frequencies of words. We could call that semantic analysis if we want. The opposite of that, not quite the opposite, but the other side of the coin for that is syntactic analysis. So we're looking at the syntax of in other words, the way that words are put together to create meaning between them and among them. Okay, so let's analyze the structure of sentences. All right, so as before, we're going to import SpaCy. And while that's working, I'm going to make a new function called NLP and use it to load our language model. Okay, and while that's happening, why don't I load a copy of Dubliners. Right, and of course, all of this is taking a very long time because it has to load a very large language model. And I'll split it while I'm at it. Yeah, how many of these do I have? Uh, 16. Okay, great. So yeah, what is 5 again? This is after the race, 2 gallants, the boarding house. So yeah, why don't we mess around with the boarding house because that's what we just read. So I'm going to call this boarding house. Now first, yeah, maybe what I want to do is extract some sentences here. For this, I don't have to sentence tokenize it because SpaCy has already done that. Right, and of course I forgot to run NLP on this. So I forgot to parse it. So the boarding house doc is, and I'm going to run NLP on boarding house. Now, if I were to force this into a list and get, say, like the 15th sentence, it would be that one. What about the 10th sentence? Huh. Yeah, so it seems to have reset itself whenever I do this. Yeah, so why don't I incorporate this list function here. And now I can get maybe the 5th sentence. Okay, so this is a fairly simple one that would be easy for us to work with and visualize. So Mr. Mooney began to go to the devil is boarding house sentence 5. Okay, so let's explore this a little bit. Like with everything, we can do the dir function And this tells us all kinds of things that we can do with that object. So the important ones for syntactic analysis are things like things that actually are not, things that are not in here. Yeah, because the important things for syntactic analysis are actually on the words themselves. So if we look at, this is going to be 1, 2, 3, 4, 5, 6. 6 or 7 should be devil. Yeah, maybe it's actually 8. Okay. So devil word equals devil 8. Okay, so this here is going to be a SpaCy token. Yeah, and now if we run the dir command on this, we should see, like a few of these methods and properties are ones that could be useful for syntactic analysis. I sort of hinted at this in one of the previous lectures. So those are methods useful for syntactic analysis are ancestors, children, root, and so on. So, yeah, maybe this would make more sense first if I visualize a sentence for you. Okay, so we have this sentence, devil. SpaCy has a neat module called DisplayCy, and DisplayCy will allow us to, actually it tells us here, it allows us to visualize dependencies and named entities and other things like that. So yeah, how do we use it? Well, we could look at SpaCy's own documentation. And yeah, I have a feeling that we could just provide something like this. I guess maybe not. So what is in this module? Okay, render is probably the one that we want. So we render a doc, and the default is to show the dependencies between them. And we probably want to, I guess it auto detects whether or not we have Jupyter running. All right, so I should just be able to give it my sentence. Oh, yeah, that's the word and not the sentence. Okay, something is working here. Great, there we go. It's a little big, but this is showing us the syntax tree of the sentence. So it's saying that the root of this sentence, you can see, is the one that none of the arrows are pointing to, and it's began. So that's kind of like the central node of the tree, so to speak. So Mr. Mooney began to go to the devil is the sentence. And what this is saying is that in order to understand Mr., we have to understand that it's modifying Mooney. So Mooney is the subject for began. So so space depends on Mr. Mr. depends on Mooney. You can see up here it's a modifier. And Mooney is the subject of began. And yeah, the predicate is this whole thing over here on the right side, began to go to the devil. To is auxiliary to go. To over here is a preposition. The is a determiner for devil. And this whole thing is the predicate for began. Okay, so another sort of classic sentence for this is, if I were to run the quick brown fox jumped over the lazy dogs, and I call this fox or something, SpaCy DisplayCy render for fox will show me that quick depends on fox, and brown depends on fox, and the depends on fox. Fox here is the subject of jumped. Over is a preposition, and it's identified this sort of prepositional phrase of over the lazy dogs. So lazy modifies dogs. The is a determiner for dogs. And all of this is part of the prepositional phrase that contains over. So how is this useful, you might be wondering? Well, lots of stuff. So you can imagine if you have a long sentence, and that sentence was something like, Mr. Darcy was a man who was certainly not as handsome as his father. You know, this is a misleading sentence from the point of view of computational analysis, because if we're doing a simplistic study and we want to just find all of the adjectives that are in the same sentence as Mr. Darcy, then, you know, it might erroneously say that, okay, well, Mr. Darcy and handsome are in the same sentence, so therefore, Mr. Darcy is handsome. We don't want to make that mistake, so we want to be sure that we know that quick is an adjective that modifies fox, and that brown refers to the fox. It doesn't refer to like a cottage or something, and that the dogs are in fact lazy. We can also use this to find the main verb of a sentence, which over here is jumped. And we can use it to find auxiliary verbs of the main verb. We can use this to break up sentences into clauses. There are lots of things that we can do with this kind of syntactic analysis here. So one thing is, just what I'm describing here is if we have a character, or not even a character, but anything at all, and we want to find adjectives that directly describe that, we can do this by navigating this tree. So you remember in the lecture about WordNet, we had this tree-like data structure, and we went deeper and deeper into it, by finding ancestors, hyponyms, and hypernyms of each element in the tree. Well, we can do the same thing with this syntax tree. And to do that, first we have to be on a word. Okay, so I started to do this. Devil, W is the word devil, and it's inside the sentence. And if I were to look at all of the things that I can do with this, one of the things is I can get the sentence that this belongs to. I think it's just sent. Yeah, I can also get, let's look at these individually. So I can get the ancestors of devil, and it's a generator by default, so we can force that into a list. And it says that ancestors of the devil are to and go and began. So to and go and began are all things that devil depends on syntactically. Okay, devil w dot children. Let's see if there's anything in there. And again, we would have to force this into a list as well. The. So the only thing that depends on devil is the. And, that's exactly what this is showing us here, that the is a determiner that depends on devil. Okay, so, what else can we do with this word? We can get lots of information about the word itself, like its lemma, its lowercase form. All kinds of stuff. Yeah, ancestor and children are the big ones. Yeah, what does this one do? Conjuncts. So, yeah, it doesn't have any of those. If we look back at the sentence, though, the sentence itself has a nice one called root. So this tells us what is the root of this syntactic tree. And in this case, it's began. So we can use this to go through all of the sentences and find all of the roots in all of the sentences, for example. So we have boarding house. We have boarding house sense, and this is all of the sentences in the boarding house. So what if we were to get the root verb in all of the sentences? So in other words, this gets us the main verb of each of the sentences. So word, well, how about sent dot root for sent in all of these sentences? Yeah, so that's interesting, because this is not a complete sentence. Yeah, so that's kind of curious. Why don't we put this into a counter so we can look at this a little bit better? And yeah, why don't we count the lemmas for these? Because maybe some are variations of the others. And actually, why don't we say that we are only interested in the ones that are alpha? Yeah, is that not a possibility? Okay, yeah, it's just is underscore alpha. Okay, so some of those are wrong, but some of them are nice. So actually, why don't I take this and assign it to some variable? And now I can put this into a counter object and find like the most common 20 or so. So be and have are pretty common verbs, but know and go and make and do and begin this is kind of an interesting slice of the boarding house, this very small story. What would it mean if one story has many more to be verbs than another? That's an interesting question that I don't necessarily know the answer to right now. What would it mean if remember was the main verb in this story? So so one thing is, this is slightly more useful. It's slightly more semantically powerful if we get the root verb of the sentence rather than simply just look at all of the verbs, because in English you have auxiliary verbs and you have the main verb. So differentiating between the two, is a big difference, right? So like, I may have gone to the store. We actually have lots of verbs here. So have is a verb, but it's an auxiliary verb to gone, to go, right? And same thing with may. So if we're interested in the verbs that have meaning, and not the verbs that simply are a grammatical construct that's used to change the meaning of the main verb, then we can use this root verb construction to get the main verbs of the sentence. Okay, so why don't we do the same thing but for adjectives? So what if we were to look for adjectives that modify some kind of proper noun? So first let's look for all of the proper nouns, all of the entities. So let's get all of the words in this doc. If that word's tag is proper noun. Is that right? PROPN. Okay, so maybe that's POS actually instead of tag. Okay, Mr. Mooney Cleaver. It thinks cleaver is a proper noun. That's pretty funny. Bailiff, Liverpool, Isle. This is a whole bunch of fluff. Okay, great. And why don't we save this? And now we want to find all of the adjectives that are associated with those. So we want adjectives that directly modify those proper nouns. So what this means is we want to, if we conceive of the tree as, let's say from the root, you have the root verb, and then you have everything else coming up out of the tree, using that metaphor, then what we want is to look for the sort of the branches of this tree. So to go up in the tree and to find the children of these words that are proper nouns. So we're going to go through each of these proper nouns. And then we're going to get all of the children, and we'll force it into a list. And why don't we put all of this into a big dictionary? However, a lot of these are just Mr. That's because some of these are a span, so Mrs. Mooney, both Mrs. and Mooney are going to be considered proper nouns. So that's going to be kind of a problem. So maybe we could just weed those out for right now. So I'm going to say proper noun for proper noun if in this list, if that lemma is not in, and I'm going to say Mrs., Mr., Mrs. I'm just going to give it like a whole bunch of these. Yeah, I wonder if I can lowercase it first. Maybe I just lowercase it. Okay, yeah, so this is doing pretty much what I want it to do. I'll add one more condition. Oh no. Okay, are we not back yet? Okay, yeah, so now we have a better list. Oh, yeah, that's right. This was going to be lower and not lemma. Yeah, and in fact, I can just throw in a few extra ones here that I know are not people. Okay, yeah. Yeah, and I have to make this lowercase apparently. So I'm going to go through all of those, and I'm going to make a new dictionary of these because I'm going to want to keep track of the children for each one. And in fact, why don't I take yeah, the dictionary can just be the string form of these, you know, so this will be person lemma, or actually maybe text for person and people. And I'm going to make that an empty list in that dictionary comprehension. And then I'm going to add this to the dictionary. So we're going to append those children. Yeah, but we're going to have more than one, so we might have to write a for loop in this. Yeah, so let's see how that worked. Okay, yeah, so this is working. It's just giving us not any adjectives at all. It's just giving us all of the possible children. So her father and apostrophe S. Yeah, Spring Gardens, Mr. Mooney. And it's giving us all of the punctuation too. perverse Madonna might be the only, and little blonde Londoner might be like the only adjective noun constructions in this story. We might be looking at the wrong story for this kind of thing. So, yeah, what we could do is filter this children out a little bit by saying, let's only get those that are adjectives. Yeah, perverse Madonna and little blonde Londoner and old Leonard are the only ones that we have here, but it's doing an okay job at finding us adjectives that are directly associated with people. But what if, we were to come all the way back up here and change this to something? So instead of doing the boarding house, let's just keep all these variables the same and change this to Eveline. And this is going to give us completely different results along the way. Yeah, so little Keeg, terrible Patagonians, and dusty Creton it thinks is like a proper noun. So not a whole lot either. Yeah, you don't have a whole lot of these. What about, what if we looked at the dead, which we haven't read? Yeah, but we haven't read that one. So what if we look at sisters? And we're going to see any people adjectives in the sisters. Poor nanny, high toast, poor James, old Cotter. Yeah, so I guess this makes sense because, one thing is it's not looking at pronoun forms of these names. It's only looking at proper names themselves. So we could change this to look at pronouns instead if we wanted to, and we get a slightly different story. Okay, so that is some of navigating a sentence tree. Okay, yeah, so what other types of things can we do? Yeah, so one is we could quantify all of these different types of relations, because all of these relations are also stored in SpaCy. And they've already been, all of these have already been quantified in a sense, so it's just a matter of accessing them. Yeah, another thing is, we can look downstream from any adjective and we could see what that adjective modifies. So why don't we try that? We're in the sisters right now. Actually, but let's change this back to the boarding house, because otherwise none of these will make any sense. So I think it was 7. All right, so first we can get all of the adjectives. So we could say word for word in boarding house, doc if WPOS is adjective. And I just got to spell it right. Yeah, so these are all of the adjectives, there are quite a lot of adjectives. Mostly adjectives describing people. Okay, so what do these adjectives describe? Well, we could just extend this just a little bit and show all of the ancestors for those words. That's just going to show us a generator, so yeah, let's put that into a list. And I'm just missing a parenthesis. Okay, so able describes woman, determined describes woman, dead describes all of these things syntactically, not directly. A bad, meat, shabby, drunkard, little drunkard, white face, white mustache, white eyebrows, mustache, drunkard. Yeah, so a lot of this is coming from, the same sentence. It's just showing us the relations if we look at them from that particular point in the syntax tree. Naughty girl, slim girl, small mouth, little perverse Madonna, young men, shrewd judge, persistent silence, little circus, little clock. So this is kind of interesting. So why don't we only look at one? So I can take a look at just one of these by filtering this even further. So what if I were to say, and that lemma is little? What are things that are described as little? Oh, right, I have to write and. Little clock, little vulgar, little tumbler, little Londoner, little paler, little time. Yeah, what if we look at small? Small mouth, small city, small hours. So one interesting study is to look at what kinds of things are described as little and what other different types of things are described as small. So and yet another thing that we could do is we could look at the objects, we could look at the subjects, rather, of certain verbs, right? So given a particular verb, who is the thing or who is the agency that does that? So for that, we would want to get the verb, right? Get the root verb, and then find the verb, and then find the subject of that. So we should just be able to get the first child. So boarding house, we have verbs. Do we have verbs already? So we have the sentences, and then we can get the root verbs this way. And then we can create the same kind of tuple here if we say we want to see the root, and we also want to see that root's children. But let's look at just the first one. So you remember we can use this function next on a generator to just get the first one. And then I have to end that tuple. Well, yeah, maybe I can do this a different way. Yeah, maybe it doesn't always have children, so maybe this is not going to work this way. So we could write it the long way. So that gets the root. That gets all of the children. And then we could say if we have at least one of those children, print that root and print the first child. Is that going to work? Yeah, why don't we make this into a list? Okay, great. Yeah, so we could quantify this by putting this into a dictionary. So we're going to do the same thing where, like, instead of characters and adjectives, we're going to have this time verbs and agents for those verbs. Yeah, so I can write this the long way and say if that root text is already in verbs, then we're going to append it to that list that's already there. Otherwise, we're going to make a new list just only containing that value. And we don't need to do this anymore, because now we should just have this variable verbs. Okay, so what things or people do was? We have Mooney and breakfast was, question was, Doran was. She is the only one that did married. Both Mooney and Polly are people that began. Night, she, and then went. What are things that made? She and he and population. She knew happens twice. He knew happened once. A house knew. Something must be up there. That doesn't sound right. He comforted. She wore. Instinct warned. She regarded. They saluted. Okay, yeah, so this is all just navigating this, this syntax hierarchy, the syntax tree. So all I'm doing is just looking at the children of any given word, which tells us the dependence of that word, or I'm looking at its ancestors, which is walking the other way up the tree. Okay, so my computer is about to run out of power, but that's just enough to get you started on sentence structure analysis in SpaCy. And I have plenty more examples of this, and so if you're interested in learning more about this, just be in touch on Zulip, and I can point you in the right direction.